Welcome, everyone. You are joining us live for 17 Minutes of Science. My name is Sarah Cheeseman. I'm a technical solution scientist at In Vivo Biosystems. It's good to be back, especially when we're talking about topics of undergraduates accessing research experiences, which is what we're going to be talking about today, a personal favorite of mine. So I'm delighted to welcome my guests, David Katz and Karen Schmeichel, who are joining us from the Atlanta region today. So they are across the country from us, although I think we are all in a heat wave. So we have something in common there. And today we're going to be talking about lowering institutional barriers to create a more equitable science community. So these two wonderful people have launched a very cool program that partners their two institutions, and they're going to tell us more about that, called the C. elegans Pipeline CURE. CURE being an acronym for Course-Based Undergraduate Research Experiences. So we all know that participating in research can provide personal, can provide professional benefits. When you're an undergraduate student, it can be a life-changing experience. It certainly was for me. And yet many kids face institutional barriers, and that prevents their entry into the research field, particularly those from underrepresented groups who may stand to gain the most from having access to that kind of experience. So Karen and David have created a really novel cure that is based at Oglethorpe University, where Karen is located, and she partners with David at Emory. So they're going to tell us about how they use C. elegans, which is the model organism we both love, to drive this curriculum. So I would love to invite Karen to say hello, and then David to say hello, and then we'll go from there.
Hi, Sarah, thank you so much for inviting us. Looking forward to sharing a little bit about this crazy journey that has arisen and has actually given us something to go with here in terms of addressing inclusivity in STEM.
And I'm David Katz at Emory University, which is just a few miles up the road from Oglethorpe, and we're a major research R1 institution, and we've partnered with Karen at a small liberal arts college, Oglethorpe, in order to have this pipeline cure.
Well, thank you both again for being here. And we have to start at the beginning, which is how the two of you began to work together. So perhaps, David, you could kick it off, and then Karen can chime in.
Sure. We actually started working together when I was a postdoc working on C. elegans. And it all started with Karen actually just trying to address this basic issue of students at a small liberal arts college really having no research experience, no access to research. And she had this idea basically to send students over to Emory to shadow and to learn about what it's all about. She had some contacts at Emory, and through those contacts, I was one of the people who volunteered to have students come over and do a very short C. elegans research project to see what it's all about. From there, it is obviously, as hopefully we'll talk about a little bit, has blossomed into a major program involving the entire curriculum, but that's how it got started.
Yeah, no, and that's exactly right. Dave has always been very education minded. He goes to elementary schools, high schools, and so it's just a real natural thing for him to say, sure, I'll take some of these kids not knowing anything about us or what we were, and he was just wholeheartedly excited to get kids doing science. And it wasn't just watching. He was never happy with anyone just watching over his shoulder. I sent these kids over and he put them to work like immediately. And they were like, what is this?
Mind-opening experience. Karen, so when did you first have this idea? How long ago?
Oh, so again, I think the story is really about, a developing idea that's shared between both me and Dave. The school that I work at, Oglethorpe, is very small. It's a liberal arts college, but it serves kind of the metro area and the Southeast demographic. So we, over 50% of our students identify as students of color. We have
Oh, there goes Karen. She was worried she might have a little trouble with her video today.
Yeah, so just filling in, at Oglethorpe University, there are a large minority population, and which is maybe a little bit surprising for a small liberal arts college, but these students typically don't have any research background coming into college. and also, at Oglethorpe didn't have any research experience. And so, this whole program in many ways evolved as sort of a series of tweaks in response to things that weren't great. So, Karen saw that they didn't have any research experience, so she sent students over. And then when she sent students over, there was a brief experience, and we both decided that, well, it's only, involving 1 or 2 students. And so we said, instead of doing it at Emory with 1 or 2 students, can we do it at Oglethorpe and have a whole class be involved? And then we instituted it, we tried it in a whole class. And by the time the semester was done, they had basically learned how to move worms and didn't really have a real strong research experience. So we said, how do we solve that? And our solution ultimately is a entire curriculum where the students reiteratively, starting in their first year, do small, research experiences on C. elegans, where they learn the system, starting in standard labs, and then ultimately branching into major research questions that the students are doing entirely in the classroom. And this is the whole, a major part of the program, that students don't have to go seek out in a typical apprentice style research like they might in my lab. They literally just sign up for the biology major and it happens.
I see. That's innovative. Karen, can you tell us how many students did you start with and where are you today?
Oh, we started out of a developmental biology class that was maybe 16 students, but now that this program has developed and it is throughout the curriculum, every entering biology major at our campus starts it and has the option to go through the whole thing. So we're talking about hundreds, well, we're small, but about 100 students every year start on this trajectory. And, in terms of coming out the other side, it's still it's an ambitious trajectory over 4 years. And so, we're seeing, I don't know, maybe a couple hundred kind of come out the other side as well by virtue of being in the various classes.
That's a lot of kids. And tell us, Karen, how have your students reacted to the program, their experience in it, and what are they taking away from it? If you've gotten that far to have graduates come out the other side, what are they doing now?
One of the interesting things, we're trying to collect data to get those attitudinal, that attitudinal feedback. If you ask them when they are just starting, they're not so happy about it. I'm new. I trained in C. elegans when I met Dave. It seemed like the natural fit for our project. And I understand the frustrations of getting used to a model organism. You're a slave to the organism. You have to be there. It's hard. It's micromanipulation. So there's a lot of early frustration. But what we see a little later on in the program is the students enter their 3rd and 4th classes associated with it. They start to have pride that they're doing this and they've gotten through the early frustrations and they're starting to see the benefits of this on the other side.
That's satisfying, right? When you've done something with your own hands and you've persevered, that feeling of coming out the other end of actually having accomplished something, that is something no one can take away from you too, as for your student experience.
I'm sure your audience will understand this. When everybody gets into research, you start out with this high and then you realize how frustrating and difficult it is. And eventually, if you get good at something, you can really start to achieve. The really magical thing is that our preliminary data suggests that we're achieving all of those stages entirely in the classroom. So these are not students, in an individual lab setting like it would be, typical.
That's interesting. Well, we'll look forward to hearing more about your data as you continue to capture it. Did I read that you've received federal funding for your program now?
Yeah, so, as part of this, so it started when I was a postdoc, but then I have my own lab at Emory in the School of Medicine. And so as one of the grants that I wrote early on was a National Science Foundation grant. And as part of all National Science Foundation grants, they have what's called the broader impacts, which is sort of something that contributes to society. And so Karen and I naturally thought, okay, this is the thing that we really want to focus on for our broader impacts. So it started out as a little bit of a side part of that grant. In the most recent renewal, it's a significant amount of money in the budget, which really helps at Oglethorpe. They have money to buy equipment and to fund students staying for the summer. One of the other things that we talk about a lot with these students is that we not only have to make it just a natural part of what they do, that they don't have to opt in, but we also need to make it so that, when they want to work on nights and weekends, or if they want to work through a summer, they're giving up the opportunity to have a job, right? And this, for many of those students, is their sole, is everything. It's for the money for them, money for their family, money to afford tuition. So we really felt strongly that we needed to actually have it be funded so that students would actually be paid to do some of this, and simply so that they could afford to not, to have their whatever other job that they would normally be doing.
Yeah, this is a huge barrier at a school like mine. This tension between getting a real job and kind of doing science, especially among students who aren't mentored very strongly with respect to how this plays out.
That makes sense. Yes. Well, hats off for getting that funding secured, because that just frees up students to participate fully and have that be their job, as you say.
Sadly, so many of the research experiences that normal students have start out on a volunteer basis. I'm sure your listeners will know that. And that's just not possible for a lot of students.
Mm-hmm. Yeah, you're reminding me that mine did too. Yes. Right. You're right. There's a lot of things to consider, and times have changed. Students' tuition is so much more challenging, that supporting themselves is important.
Yeah. And I just want to add one more thing. There are quite a few opportunities out there for interested students to get that research experience in a summer. But these are some of the programs that are existing and funded by NSF. They're very competitive. So if you have a student who had a rough start, right, whose GPA isn't exactly where they want it to be, they're going to be excluded from those programs as well. So by having this embedded within a curriculum, it's easier. No one has to apply for it. You can try it out.
That's really excellent. Good point. I want to go back to the beginning of where we started, because I was just revisiting the title of our discussion today, which is about creating a more equitable science community. And I'd love to hear from both of you. Perhaps Karen, you could start, about what does that mean, and tell us the kinds of thoughts you've had as you've gone along this journey together in addressing equity.
I think a lot of it's access. It's making sure that we are addressing student needs in a way that gets them kind of up to the playing field, right? I mean, a lot of our students don't know the questions to ask, and this increased access is a really important piece of equity. Just kind of, again, not necessarily playing any game to kind of get into the research labs, but certainly for it to be there, and for you to be able to find out about it pretty quickly, and for you to plug in regardless of where you started.
Do you want to tell them about the cartoon that you sent me about this? Or I can do it.
No, why don't you go ahead? You do that.
Yeah, I mean, basically, Karen sent me this cartoon about, people trying to watch, I think it's a baseball game or a sporting event, and there's a tiny little kid who can't see over the fence. And so they think, making it equitable is stacking up boxes so the kids, so that kid can see over the fence, like the taller person who's standing next to him. Whereas the real equitable thing to do is eliminate the fence so that the kid can just walk up and see it. He doesn't need all those boxes stacked up in order to see over the fence. And this is what we're trying to do. Research has so many benefits, and we want to make it just a natural part of what you experience, and give everybody the opportunity without, so many programs are designed to boost up the students. We just want to lower the whole barrier completely so that they don't have to do that.
I've actually seen that graphic you're describing, so I can picture it in my mind. That's a good analogy. Removing the fence, right? I thought you were also going to add to that and say that if you haven't had exposure to research, you also need that person next to you to guide you with the
Yeah.
go, right? So you know how to engage.
Right.
So unknown to you.
And our goal here is not to turn every student who transitions through this curriculum into a scientist. It's certain that's definitely an option, but there are so many other things, this mentoring, this constant, seeing yourself in science. And this is another part of equity as well. Not only do students need to identify themselves as scientists, but they need to, they need voices and people showing them this is how it happens, and this is how you could be a part of it. And here's someone potentially who looks like you doing this, and that you might identify with, and we can help you explore that in whatever role you might be interested in. So certainly maybe we're kind of launching the next great researchers, but it's also just an important experience to say, well, gee, I don't like this very much. I'm going to respect it more, but I'm going to choose another path. And I think we both agree that that's a really important part of this as well.
Yeah, that's a success if we create an informed student who turns out not to love science, but really gets it and understands the process.
Agree to all of that. We just need a more scientifically literate population. And I've said this so many times on this show, because I know we're sort of as our community preaching to the choir, but we're just seeing that experience right now with COVID, when there is not enough basis of understanding to evaluate all that information that's coming at us, scientific information. And if you start speaking to people in a language they don't understand, we just shut our brains off. We're not going to listen. So
there is definitely a transition for students when you tell them about science, even if you tell them about experiments. It's not the same as having designed an experiment. When they finally do that, they realize how those COVID, trials were designed, and they have an appreciation for it, and they believe it more because they understand the process.
Mm-hmm. That's a great example. So we're coming on our last minute. I'm wondering if I'm kind of going to put you both on the spot, but can you think of a student story that you'd like to share? Somebody that just pops into your mind as a notable?
Well, we had so the program at the last class is run by a postdoc in my lab. So that's another benefit that we didn't get a chance to talk about. But one of my postdocs was talking about their own research, and we had been talking about it for a long time. And a student just comes up and says, Dr. Carpenter, if that's right, shouldn't the methyltransferase also have the same effect? And we had never thought of it. And we said, you know what, you should do it. And so he was the first one to do that experiment. That experiment eventually got included in our paper. And he is an author on the paper for doing and coming up with that experiment entirely within the classroom.
I write a lot of letters of recommendation for the students in the biology program. And I continue to get, missives from those students, maybe some of the ones who are a little bit more resistant to the whole thing, but saying, could you write me a letter? And what I really want to talk about is what I learned from going through all of the C. elegans training. And, it makes me smile. And, I kind of feel like I told you so, but it creeps up on them. And it's almost sometimes only afterwards that they start to realize the value that they got. And so I think that makes me smile, as well as the fact that all over the building, there are little cartoons that kids draw all over whiteboards, and just their version of some cartoon version of the C. elegans in it. So it's really a part of the culture at this small school.
And Karen pointed out that the president of the university mentioned C. elegans in his commencement speech. So if you make it there, then, the program has really been a success.
You have arrived when they know how to say it right.
Exactly. Could you imagine the president of the university being able to pronounce, Caenorhabditis elegans?
That's a win. Oh, that's a good story. Well, thank you both for sharing all about it. The anecdotes, the journey. It's very inspiring to hear you tell us what you have created, and hats off to you both for the work that you're doing, and most especially to your students for their perseverance and energy to embrace the worm as a model. So
thank you for having us.
Yeah, thank you.
And I thank everyone for following us today, and we will look forward to seeing you next time. Until then, stay cool. Take care.